Hello, Garnet again, and I've been asked to try to explain something. It's in relationship to this, the nasal light, and the idea of stimulating the blood with light energy. I'm going to tell you, I'm going to warn you that this is more technical. And for those of you not really interested in the technical aspects, then you can just either listen for fun or not bother at all. I don't know exactly how long this will take. I've never really tried to put it all out loud at one time. I'll do my best. I'll try to keep it as honest as I can, meaning that I understand it to a degree, and past that point I don't. I'm not sure how many people really do. It's something that has been an interest of mine for a long time. Okay, so basically I think you understand that with the Neurolite that we have this nasal light, and that we recommend doing things like this. The idea is that the light is able to stimulate the blood because in the nasal passageway the mucosa, the lining, is so thin, it's a little bit like a window, not quite transparent, more translucent, but that as the light energy passes through the nasal mucosa, it goes into the capillary network and into the blood. Okay. I'm not sure exactly where to begin. The understanding as to how this action takes place and how it gives us benefit is being understood progressively. The understandings are evolving, and we're getting a better and better understanding of that. I think it's quite well understood now that shining light, especially of certain wavelengths, especially, but not only, but especially the visible red and the near infrared, which is mostly invisible to the human eye, that those wavelengths, those colors, if you will, are especially capable of exciting or stimulating the mitochondria in cells. So cells make up tissues, tissue make up organs. When you shine light in those wavelengths on tissue, it affects the cells. In the cells live the mitochondria. The light energy is able to penetrate to some good degree the cell membrane, and the mitochondria with the cytochrome C oxidase, the CCO, the microscopic elements on the mitochondria absorb the photon energy. There is what's called a transduction, the transducer, where the excitation that we call energy is transferred from the photon and into the mitochondria, and through a chemical physical reaction we get more ATP. Okay, that's true, and we know it's true, and it's used to great benefit. Now here's the issue: is that the same process that goes on when you shine light into the blood? And this is the story I want to tell a little bit. One person in our group sent in a message on Facebook saying, well, even if there is a charge, how is that charge maintained in the blood? Because the blood has to travel a distance. So that's a little bit of what I want to talk about right now. The first thing is how the charge is created. This is very new information that explains a lot. I'd mentioned this in the previous short video. The best explanation that I've come across is from Gerald Pollack in his book, The Fourth Phase of Water. I highly recommend it. It's technical, but if you have an appetite for that, it's extraordinary. The first half of the book is pretty much all you need. The second half goes into extraordinary detail that is amazing to those trained in science, but hard for those of us that aren't. Okay, it's also in combination with recent German research that shockingly makes the point that about 2/3 of the energy in our organism is obtained through thermal excitation, the light and the heat resulting from light, and about 1/3 in nutrition from the foods that we eat. And if that seems unlikely or even preposterous, I would say eat the best diet in the world, get placed in some kind of environment that has no light and no heat, and you'll see that you'll die soon. It's called freezing to death. And this appreciation that we actually have a kind of, and I have to be careful here, a kind of photosynthesis. Plants, of course, have a photosynthesis. You know, they use water and carbon dioxide. I'm not saying that. But we absorb light, especially the long wavelengths, the visible red and the near infrared, into our body through our skin when we're exposed to sunlight. I'm going to be jumping a little bit from topic to topic. Each one of them is worth, hours of exploration and discussion. So the idea that we absorb light all the time makes something like this not so peculiar, because we're already doing it. And you'll see there's something else that we're already doing that I'll explain shortly. So whether it's coming from the sun, right, or whether it's penetrating from the sun into our skin, because there is a phenomena that occurs when you have an artificial source like this laser diode here. Believe it or not, as I do this, I feel a sensation that moves up and down my arm. You could say, well, I'm just imagining it, but I still feel it when I close my eyes. And that this is not just shining on my skin, but is actually going in through my skin, and depending on the fatty deposits and so on, it's penetrating quite deeply, at least a centimeter or so, into my tissue. In other conversations, I've talked about taking what I'll call a dumb old flashlight, nothing so special, and in a darkened room, putting it in the palm of your hand, and you'd notice that at the back of the hand you can see red, orangey, glowing light, which means, of course, that this dumb old flashlight is actually creating light that goes right straight through my hand, which is about the palm of my hand, maybe, what's that, maybe more than 2 inches thick. So we absorb light all the time, and this recent issue made clear mostly, although not only, mostly by the work of Jared Pollack and his whole team of academics, is that when water is exposed to thermal excitation, aka light, especially light in that longer wavelength, the red near infrared, it creates a process in the water that we would normally call structured. I've also explained he calls it EZ water. E and Z being a short acronym for exclusionary zone or exclusion zone, because when the water goes into this fourth phase, into this semi-crystalline state, it seems to exclude, kind of push out or not accept all kinds of particles. So the water, in a sense, purifies itself, pushes all those soluble particles out, so that this water is now a zone of exclusion. It excludes them, so it's called exclusionary or exclusion zone water. Then he calls the other water that is nearby bulk water. And so easy water is this exclusionary zone, also what we call structured water. Now, there are different ways of creating this easy water. It seems to want to get close to what's called hydrophilic substances, substances that like water, as opposed to hydrophobic, that repel it. So even when the water moves against a hydrophilic structure, that movement, that action seems to then invite this structuring. For us, it's not so much this frictional relationship like a stream passing over rock pebbles, but instead the activation that comes from light, from thermal sources. And his book goes into glorious detail showing that this is true. Very inspiring and exciting to me, I can say, and I'm sure to a lot of people. So by shining light into the bloodstream, because the blood is basically plasma and plasma is basically water. So you have this water that contains different elements, and we end up calling it blood. And the water in the blood is shifted, I suppose, I don't know what the verb would be, into a semi-crystalline state, a structured or easy water state. Now when that happens, there's a charge differential. The structured water becomes negatively charged, and the non-structured water or environmental structures are positively charged. What this does is it creates a water battery. So the water becomes a battery with a charge. And, oh, the subject is big. I'm trying to stay logical here. I'll address the specific question, then keep on talking. The question that was asked in Facebook was, how does the blood, the water in the blood, sustain the charge? Well, I'm going to pull out a book. This is Biologically Closed Electric Circuits by Bjorn Nordenstrom. I've been lugging this book around. It's big and heavy for a long time. It was published almost 35 years ago, and it's one of the most amazing texts I've ever come across. Very technical, but this gives you some idea of the detective track, the Sherlock Holmes that's been going on for a long time. What's explained in this book, and I'll sort of jump a little bit right now, I don't know how coherent this explanation is that there are what he calls biologically closed electric circuits in the body, and that the vascular system, the blood vessels, are a main, not only, but are the main conduit for this biological electric circuit activity. So, to answer the question about how is the charge in the blood maintained, he explains, and explained this, well, of course, 35, almost 40 years ago, it took a while to publish the book after the research, is that the vascular walls act as insulators, so that whatever charge is within the bloodstream is maintained because of the insulation of the vascular wall. Combine that with the fact that the red blood cells, the erythrocytes, which don't take up the charge, also act as a substantial insulation within the blood flow. So you've got the vascular wall and the red blood cells acting as insulators to sustain and maintain the charge as it moves through the system, which is beautiful. So when you stimulate the blood with a thermal source, light, especially in the red near-infrared range, what it does is it creates this semi-crystalline structuring that by its very nature separates and makes a charge. The crystalline structured water has a negative, the bulk and non has a positive. Now combine that with the fact, and this is also this is Swedish research from 30, 40 years ago, but has now been validated through many studies in many countries over time, is that when tissue has a problem, when it's diseased or necrotic or is destroyed or injured, it actually gives off what's called a coronal discharge. It's a catabolic energy, that the energy within the system that is normally regulated is escaping. It flashes out. And this is also understood even when an organism dies, that there's a flash of light. So light coming out is not necessarily a good thing. Light as energy is contained within the organism, and it is subtly dancing in and out of the organism with the environment. So these discharges in diseased or affected or injured tissue is actually a loss of containment. It's not a closed system anymore. It opens and flashes out. What that means is that there's a deficit there. And that's the beauty of this charged fluid that we call blood, and I'll talk a little bit more about that. As it's traveling through the systems, when it encounters or detects, I'm not quite sure what the verb is, when it encounters this deficient tissue base that has been lost because of a disabled or injured or malfunctioning process, then the charge offloads into that tissue. And part of that, am I sure? No, I believe also then will jump and make an interface with the mitochondria. So I don't think the mitochondria, the CCO and even the nitric oxide aspect, which is vasodilation, I think it's real for sure. It's been proven enough, but I don't think it's the entire process. So there's some kind of energy matrix process that is also involved at a more basic biophysical level. Also understand that the body is mostly water, and that you can divide the water, basically water in the cells, we would call it cytoplasm, and water outside the cells. Now the water that's outside the cells also can be divided to the water in vessels and the water outside of vessels. So the water outside of the vessels is called interstitial fluid. It's neither in the vessel and it's neither in a cell. So basically, you can see I warned you, it's a bit technical, that you've got water in the cells, you've got water outside the cells, and you've got water in the vessels. And these three are always in fluid exchange back and forth. So the charged water plasma base in the blood from the light will then carry its charge into the interstitial fluid, and from the interstitial fluid through the cell wall by transport systems and into the cytoplasm. In the cytoplasm, swimming around, I suppose, stupid analogy, are the mitochondria. So what you see is a continuity in water, and also a continuity in the charge that the water can accept, sustain, and transfer, that transducer aspect. So consider, I think it kind of blew my head when I think about it, but think of the watery nature of our body as also meaning that we can be one large battery. And it goes into more things where even the cell membrane will have a certain voltage, and that voltage has to be at a certain level, and on and on and on it goes. So it's a whole biophysical approach. I don't know how long this has been, I don't know, maybe 15 minutes or so. I apologize for two things. One is that it's technical, which may not suit you. The other is that I'm pretty sloppy at trying to explain it. Truthfully, I've never tried to say it all out loud at one time. But basically, water can serve as a battery. It can take on a charge. The basic way it seems to take on a charge is through thermal activation, meaning light and heat, which is an aspect of light. That when it has a charge, it can move through the vascular network because the vessel wall acts as an insulator, and also the red blood cells themselves act to sustain an insulation in what we'll call the matrix. That it flows through this biologically closed electrical circuit, that wherever there are tissues at a cell level that are injured or having trouble and catabolically are doing the coronal discharge, they're losing energy, and it expresses biophotons as actually detectable light, that then the charge in the blood will transfer out of the vessel into the interstitial fluid. Now there's no more vessel insulator, so it's freely attracted to the deficit. It'll go to the cell wall, penetrate the cell wall, into the cytoplasm, and encounter the mitochondria. But I also think a number of other processes. I don't think it's limited to mitochondria. But that's just me thinking. Okay, that's that. I hope it helps. It's kind of complex and more complex than my own understanding. So that's my best. Thanks. Bye-bye.